Hello and welcome to Lesson 5.3 on CPCTC. And CPCTC stands for Corresponding Parts of Congruent Triangles Are Congruent. In this lesson, we're going to look at ways to use triangle congruence theorems as a step in proving other parts of triangles to be congruent. If we know that two triangles are congruent, then we know that every corresponding part of one triangle is congruent to every corresponding part of another triangle. In a proof, we're going to use the phrase corresponding parts of congruent triangles are congruent, or CPCTC, as the reason why we can equate corresponding parts in a proof. For example, here we have a triangle, ABC and triangle CDE, and we want to prove that angle B is congruent to angle D. However, I can't do that until I prove that the triangles are congruent. So, first thing I'm going to do is I'm going to analyze my diagram. I'm going to see what do I need in order to make this proof work. Well, I see already that I have a pair of vertical angles. And looking at that now, it looks like we're going to use AAS to prove my triangle is congruent. So let's write down the givens. They give me that BA is congruent to DE, and that angle A is congruent to angle E. Well, let's write that again. BA congruent to DE, angle A congruent to angle E. And we've already analyzed our diagram to see that we need to say that angle ACB is congruent to angle ECD by the vertical angles theorem. So therefore, triangle ACB is congruent to triangle ECD by AAS, angle, side. Now that I've proven that the triangles are congruent, we know now that every single piece of each triangle will be congruent to its corresponding part in the other triangle. So this allows me to say that angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. CPCTC. Proof is done. Let's take a look at another one. This is one of those classic overlapping triangles, and looking at this, my overlap is going to be segment GI. So I need to be aware of that. Once I include segment GI, it looks like we're going to prove the triangles to be congruent by SSS. And once I've proven the triangles to be congruent by SSS, it'll be easy to prove this by CPCTC. So let's write down what they give me. They give me that FI is congruent to HI, and that FG is congruent to HG. And you're going to write down your givens again in the next line. Now, we need to establish the third side. We've got the two sides listed here, but we need the third side listed. Well, that's GI, and GI has to be congruent to itself by the reflexive property. Once we've established all three sides are congruent, then I can say triangle FIG is congruent to triangle HIG by the side postulate. Now that I've established that the two triangles are congruent, that means that every piece inside each triangle is congruent to its corresponding piece in the other triangle. So that will allow me then to say that angle FGI must be congruent to angle HGI because corresponding parts of congruent triangles are congruent. CPCTC. And we're done with our proof. All right, let's take a look at this guy. I believe he is going to be a little bit harder because if you look, they don't give us any congruence relationships, but I do see a shared line right here. I see that this is a shared line, and I see that we have some parallel lines. KL is parallel to JM, and KJ is parallel to LM. So looking at this, I know I'm going to end up using some of my parallel line theorems to make this work. Specifically, I'm thinking alternate interior angles, because if you look, if we were to extend these lines right here, I would be able to say that this angle is congruent to this angle by the alternate interior angle theorem. And here, if I extend my blue lines, I'd be able to say that this angle is congruent to this angle by the alternate interior angles theorem. And so I think we're heading towards ASA, angle, side, angle, to prove the triangle is congruent. So let's do that. Start off by writing your givens. So we've written down our givens. And I'm going to go ahead and list my reflexive piece first, that JL is congruent to itself, because it's really easy to do right there at the beginning. And that gives me my side right there. Okay. Now, let's look at these angles. Well, I'm able to say that angle KJL is congruent to angle MLJ. Well, they're alternate interior angles. So I'm able to say that by the alternate interior angle theorem. And let's look at the other pair. The other pair would be, oh goodness, angle KLJ is congruent to angle MJL, again for the same reason. They're alternate interior angles theorem. Well, we just went through and found the two A's, right? Now we're able to say that triangle KLJ is congruent to triangle MJL by the ASA theorem. Now I've proven the triangles to be congruent. It's really easy then just to say that KJ must be congruent to LM, that KJ must be congruent to LM because corresponding parts of congruent triangles are congruent. All right, let's take a look at this proof now. This one, wee bit of a doozy, because we're not given very nice things in this proof. Let's see what we have. We're given that UW, this tiny segment here, is congruent to VX, this segment here, and that XT, this segment here, is congruent to WT, this segment here. Now thinking about my overlapping triangles, I see that both triangles would have angle T, but I'm going to redraw them so that it's much easier to see what's going on. This is one of those that would really benefit from multiple views. Cool. Where this is U, T, there's a W here, and that's X. This is V, W, X is here, and T. Things we know to be true. We know that XT is congruent to WT, and we know that T has to be congruent to itself. And if you look, we have sorry, one second. We have a segment here. Oh wait, I've got all my markings backwards on this, guys. I'm sorry. Give me a second. Whew. That's not good. So that needs 1 mark. Those need 2. 1 mark, 2. Okay. Looking at this, you can see that if we use the segment addition postulate, we can get that UT is congruent to WT. Or sorry, VT. So this one's going to take a bit more work than the last one. But once I prove it, it looks like I'm going to use SAS to prove the triangles to be congruent, and then CPCTC to prove the angles congruent. So let's write down our givens. So I've written down my givens, and I've gone ahead and written in the reflexive property that T must be congruent to T. Now, because I know I need to use the segment addition postulate to work on this UT and VT segment issue, I'm going to go ahead and convert all of my congruent symbols for any of the segments into equal symbols. And once I've done that, I'm going to write out the segment addition postulate for both XT and WT. So, sorry, VT and UT. So I was able to write that VT equals VX plus XT because, looking up here, segment VT is composed of VX and XT. Similarly for UT, UT is composed of UW and WT. Now we can do some really lovely substitution steps to get things that we could set equal to each other. I am going to go through, I'm going to work on UT, and I'm going to make 2 substitutions in UT. I know that UW is congruent to VX. And I know that WT is congruent to XT. The reason I did that is that now this piece here matches this piece here. And so now I'm able to say, through the transitive property, that VT is equal to UT. So just to back up, this was substitution, property of equality, and this was my transitive property, and once I'm able to say that they're equal to each other, I can also say that they're congruent. VT is congruent to UT by the definition of congruent. And once we establish that, we've now established our SAS pattern. So I'm now able to say that triangle UXT is congruent to triangle VWT by SAS. And once I'm able to prove the triangles are congruent, I can prove the angles are congruent. Angle UXT is congruent to angle VWT because corresponding parts of congruent triangles are congruent. All right, this next proof, I want you to pause the video and try on your own, and then start the video back up and check your work. Okay, go ahead and check your work. Make sure you've got it. If you have any questions, jot them down on this page, and we'll go over them first thing in the morning, or first thing start of class. Thank you very much, and I appreciate your hard work and patience, and have a wonderful rest of your day.